practice final. So this is to prepare you for your final next week. So number 1, I would definitely graph it. I would write down the segment. So AC, and then B is in the middle. And then I would write down the information. So AC is 2x plus 8. So it's this whole side together. AB is 4x minus 16. And BC is 3x minus 6. So they want to know what the value of AC is. Well, first I need to figure out what x is. So these two segments add up to the big one. So I'm going to add these together. So I have 4x minus 16 plus 3x minus 6. And both of those are going to equal 2x plus 8. Then I'm going to combine like terms and solve for x. So 4x and 3x is 7x. And negative 6 and negative 16 is negative 22. And that equals 2x plus 8. Just going to need a little bit more room to solve this. So I'm going to take this part out for now. And I will solve this. Okay. So now from here, I'm going to subtract 2x to both sides. And I get 5x minus 22 equals 8. Add 22 to both sides. And I get 5x equals 30. Divide 5 to both sides. And x equals 6. From here, I'm going to plug it back in. So I'm going to plug 6 back in for x. Okay, well, what do they want? They want side AC. So I'm going to plug 6 back into that first segment, the AC. So I have 2 times 6 plus 8. 2 times 6 is 12 plus 8, which would give you 20. So that's number 1. So draw it, write out what each segment is worth, find x, and then plug back in. So that is a lot to do in one problem. All right, number 2. This is about midpoint. So midpoint's rule is you are adding the x values together, dividing by 2. You're adding the y values and dividing by 2, and you're finding the midpoint. So if x and y are over here, the midpoint is halfway there. Okay, so we know that x is negative 1312, and we know that m is 2, 4. Okay, so let's think of it this way. So how do I get from negative 13 to 2? Okay, well, that's adding 15. That's how I would get there. So what do I need to do? I need to add 15 the other way to get to the other endpoint. So 2 plus 15 is 17. Well, which is the only option that has 17 as the x value, is D. Okay, so 17, negative 4. So if I plug in this point and this point into my equation, I will get the answer of 2, 4. Okay, so this is from the first unit we did this year. All right, the next one, number 3, is about angle bisector. So angle bisector cuts something evenly. Okay, so AEC is right there, and they said the angle bisector is right here, which means that these two sides are congruent. So that means this side is also 2x plus 1. Well, what do I know about straight lines? They always add up to 180 degrees. So I'm going to combine like terms and find out the value of x. So how many x's do I have? I have 4 x's. And then what is my constant? Well, 1 plus 38 is 40. So I have plus 40. Now I'm going to subtract 40 and divide 4. Okay, so 4 into 140. So that would give you 35. So the answer is A. A is your answer. All right, number 4. Now let's think about this problem. Okay, these two angles add up to this square, which is 90 degrees. So these two angles need to add up to 90 degrees. Well, instead of doing all of that work, let's look at our options. So 71 plus 109. I don't think that's 90. 8 and 48. That does not add up to 90. 33 and 33, that's 66, not 90. So your only option is the last one. 41 plus 49 would give you 90 degrees. So that's your answer. If it's not that simple, you would solve this problem down here, find x, and then plug it back into the angles and find the value of each. But use your options. Use your multiple choice options. Okay, number 5. This is all about, can you understand the idea of segments? So ML and MN. ML and MN. Does it say anything about those being equal? No. Same with NO and ML. There's no indication that these two are congruent. What could be an indication? Well, an indication could be if there was like a little dash in them. But there is no dash, so you can't prove that, okay? LM and MN equal LN. Well, that is not an actual segment. There's a curve in it. So your only option is A. And let's see if that makes sense. This segment plus this segment add up to this segment. Yeah, that's addition segment postulate that we talked about. Adding two segments together to make the big segment of MO. Good. All right, number 6 and 7 is all about what information do they give you? What hint do they give you? So they say something about bisecting, and this is an angle. So which one of these options talks about angle bisector? Well, A does. Okay. All right, number 7 is talking about how can I prove that angle 1 and angle 3 are congruent? Well, what are angle 1 and angle 3? What type of angles are these? Well, they're vertical angles, so 7 is D. So looking at the different options and seeing which one connects, which one can answer these proof questions, okay? If it was complementary, that would mean that those two angles added up to 90 degrees and they would be next to each other. Supplementary angles add up to a straight line, so they would be next to each other and they'd add up to 180. All right, moving right along. So 8 and 9 is parallel lines cut by a transversal. So this is unit 2B. Okay, so angle A and angle B. So these angles either are congruent to each other or they add up to 180. So angle A and angle B, 110 and 60. So 110 and 60, does that add up to 180? It does not. So therefore A and B are not congruent. Or A and B are not parallel. Okay, so we're trying to see if these lines are parallel or not. Okay, so let's look at line B and line C. So 60 degrees and 65 degrees. Those angles are alternate exterior. Okay, so these angles should be congruent. Well, is 60 and 65 the same? No, so B and C are not parallel lines. The next one, A and C. Okay, so pretend that the middle line is not there. Okay, so I have line A and line C at 110 and 65. So what you could do is 110 should be over here. You could put it over there because these two angles are congruent. They're both alternate exterior. Okay, does 110 plus 65 add up to 180? No, it does not. So it's not C. So your only option is D. So sometimes you have to go through each one and see if it's true or false based on what you know with geometry. Use those notes, okay? All right, the last example is this line and this line, and they're talking about angle 60 and angle 120. I'm trying to find angle relationships between them. Okay, well, does 60 and 120 add up to 180? Ding, ding, ding. We've got a winner. Those are parallel lines. All right, number 9. So we have to figure out, so these two angles are called alternate interior because they told me that these are parallel lines. So I can say that those two are alternate interior. So I'm going to make them equal to each other and solve. So I'm going to pause and solve and come right back. All right, so we should have gotten x equals 29. All right, from there, now that we have that, So we have x equals 29. Remember, it's select all that apply. So now I need to look at the other relationship. All right, so I know that this angle and these two are parallel lines. So what's the relationship between these two? Well, they're alternate exterior. So I can also make those equal to each other. So I have 9y, cover that up, plus 26. So how can I solve this if I have an x and a y? Well, I already figured out that x is 29, so I can plug that in. So 3 times 29. So 3 times 29 is 87 plus 38. So I have 125 equals 9y plus 26. So solve that and find the value of find the value of y now. So y equals 11. So x equaled 29 and y equaled 11. So for this one, you would have chosen I and m. All right, moving right along to number 10. So what's important for number 10 is just focus on one vertice. So I'm just going to focus on one coordinate. So A is negative 4, 2. And then it says reflect across the x-axis. Well, that rule is y negative x because it's flipping over the x-axis. So if I had negative 4, 2, what would that change to if I applied that rule? Well, that would mean the x would stay the same and the y would change to a negative. So which one of my options has that as a choice? Negative 4, negative 2. Well, C has that as a choice, okay? So that's what I would pick. If that didn't work and you're like, oh, 2 of them still work, okay, now look at the B's, okay? So only focus on one coordinate at a time, okay? The next one is about translation. So that was going left, right, up, or down, okay? So if your x is positive, that means you're going right. And if your y is positive, you're going up. If your x is negative, that means you're going left. And if your y is negative, that means you're going down. So if it says you're going down, you need a negative y. And it says going to the right. So that means you have a positive x. So which one of these vectors shows a positive x and a negative y? Well, that would be A. Okay? B would be left and down. C would be right and up. D would be left and up. Okay? So just knowing the difference between the different directions. All right, number 12, y equals 11. So we're going to focus on the value of the y's. So how do I get from 7 to 11? Well, I add 4. So how would I move that to the other side? So you can draw like a little picture to see what's going on. So negative 5, 7. So if I had one over here and I'm going up 4, that means I need to go down 4 the other way. Okay? So what is 11 plus 4 the other way? Well, that would be 15. So the new y value is 15. So that would be B. Okay? The x doesn't change. The y, you're going to flip it across the y equals 11, that straight line. All right, going 90 degrees clockwise. So it says at the point T. So what you can actually do is make a little coordinate graph at where the T is and pretend that that's your origin and kind of see what you're working with. Okay? So 90 degrees clockwise, that means you're going right. So let's say I have this M, and this is my new M, so that would actually be 270 clockwise. So A is wrong. If I have this M to this M, that's 90 degrees counterclockwise. It's going to the right. It's going left instead of right. Okay, the next one, M to this M. Oh, this is 90 degrees counterclockwise also. Oh, wait, no. Hold on. Oh, this is right. So M to M1 is 90 degrees clockwise. Sorry, I had it wrong. So you always want to go from this image to the ones with the little dashes. So M to M1. So 90 degrees clockwise. And then the last one, M all the way over to M1. This would be 180. So this is 180. This is 90 counterclockwise. This would be 270. So your answer is C. All right. Number 14. Again, we want to figure out 90 degrees counterclockwise. So I'm going to use my little rule. I found this little neat rule that has all the different types. So 90 degrees counterclockwise is negative yx. So negative yx. So I'm going to pick a point and see which one works. So let's say I picked C and C1. So C is 1, 0, and C1 is negative 1, 0. Well, did the numbers switch? No, they need to flip. All right, so now let's try the next one. So again, I'm just picking C and C1 and see if I can see the difference between them. So 1, 0, and then the next one is 0, 1. Okay, well, the numbers flipped, so that might be the answer. All right, let's try the next one. So C is 1, 0, and then C1 is 1, 2, 3, 4, up 2. So this is actually a translation, so it's not C. All right, and then the final one, D. Woohoo! You guys are doing great. Keep it up. All right, so I have C is 1, 0. And then C1 is 0, negative 1. Okay, well, if I looked at my handy-dandy chart, that would be this one because they flipped, and then the new second number is negative. Okay, so that would be actually 90 degrees clockwise. So it's not D, therefore it's B. So I checked and made sure that all the other choices don't work before I picked B. All right, number 15. So this one's kind of tricky. We're trying to find this outside value, okay? So what I do is I figure out what relationships I know. Well, I know these three angles add up to 180. And I know that this angle and this angle are vertical angles, so they're equal. And I know that this angle and this angle and this angle also add up to 180. And then I know that these two also add up to 180 because they're a straight line. So looking at the different relationships and figuring out how can I find that outside number. So 47 plus 33 minus 180. So I know that this angle right here is 100 degrees and this angle right here is 100. So then I could figure out, all right, so using the relationships between triangles and the straight lines is how you're going to get through this, okay? There's also another rule, exterior angle theorem, where these two angles add up to this outside guy. So we've got, I know there's a lot going on here, so let me erase so you can kind of see what I'm doing. Okay, so I figured out that this angle is 100 and this angle is also 100. So exterior angle theorem means that those two add up to this outside angle. So 100 plus 48 is 148. So that's the answer. But let's say, oh, I don't remember that, okay? Well, what you could do is this one, add up, and then you can find that last angle, okay? So 148 minus 180 is 32. And then you could do 180 minus 32, and you'll get, again, 148. Okay, how do I bubble this in? So I'm going to put a 1, a 4, and an 8. You don't really need to worry about the plus or minus. If you want to, you can bubble it in if you want to. You know, if you want. So 1, 4, and then 8. So in each column, there's only one thing bubbled in. Okay? Old school Scantron. All right, number 16. Again, we're connecting what letter goes with what letter on the corresponding triangles. So C goes with Q. So C goes with Q. Awesome. C goes with Q. Oh, C goes with P. Nope. C goes with R. Nope. So I already took away two choices by doing the first letter. Now let's talk E should go with R. E goes with R. E goes with P. Nope, it's not B. Therefore, it's A. So the order matters on how they write the triangles. All right, number 17 should look very familiar. It's been on many of your homeworks and notes and all the good stuff. So refer to the complete. So A, B, C. So I've got A, B, C. That's some of this triangle. So if I wanted to figure out what corresponds to A, it would be E. Okay? And then what would correspond to B? That would be D. And then what corresponds to C? It's C. So you would have E, D, C. So which choice is it? It is B. All right, awesome. Okay, this one. This line is the exact same line, okay? So we have angle, angle, side, which is very different than if you had angle, side, angle. An example of angle, side, angle is if you had this. It's very different where they share the side together. These angles do not share the same side. So angle, side, angle is this example. Angle, angle, side is this one. So careful on those. All right, number 19. So which theorem can we use to conclude? Well, I know that these two angles are congruent because of vertical angles. So please don't just make up sides because they're there. You have to prove it for a reason. So side, angle, side. The angle is in between the two sides. So there we've got some sass. B. All right, number 20 has been on your homework also, so we'll go quickly through it. So we need SAS. We have a side, we have an angle. So what do I need? I need another side, okay? And if you notice, it is side, angle, side. So I have to be really careful on where I put that information. So side, angle, side. Side, angle. Well, if I put a side over here, I'd have ASS. Remember, we cannot have that in geometry. Oh my goodness. Okay, so I need side, angle, side. That's why it's very important that you pay attention to the sides. Okay, so I've got AG and OL, which is B. All right, we're almost there. Last one. So leg angle congruence. Okay, so that's not hypotenuse leg. Hypotenuse leg is if you would have this angle and then you have a side. You have a leg and a hypotenuse, okay? Leg angle is another way of saying angle, side, angle, okay? So I have two angles. What do I need? I need the side that's in between. So what is the side that they share, okay? What is the side that the two angles share? So we need AB and DE. So that would be A. Okay, so thank you so much for joining me on this review, and good luck with your final. All right, x equals 29. 29 is x equals.